You're listening to a song. It's nothing special, just a piano melody, a slow build, a voice that sounds like it's speaking directly to you. And then it happens. A shiver runs down your spine. The hairs on your arms stand up. Your breath catches. For a moment, the world stops. You've just experienced musical frisson, one of the most mysterious reactions the human body produces. You didn't choose it. You couldn't predict it. And scientists still can't fully explain why a sequence of air vibrations can make you feel something so powerful. In 2011, the neuroscientist Valorie Salimpoor at McGill University made a discovery that changed how we understand music. She put participants in an MRI scanner, played the music they loved, and measured their brain activity. What she found was remarkable. The same brain regions that light up when you eat chocolate, have sex, or take cocaine, the caudate nucleus and the nucleus accumbens, light up when you hear a piece of music that gives you chills. But here's the twist. The dopamine wasn't released when the music peaked. It was released in anticipation of the peak, during the build-up, the pause before the chorus, the moment you know something beautiful is coming. Your brain rewards you not for hearing the music, but for predicting it. Music is, at its core, a system of expectation and surprise. This was first demonstrated in 2001 by the neuroscientist Robert Zatorre and his colleague and Blood at the Montreal Neurological Institute. They found that musical chills activate the ventral striatum, the amygdala, and the orbitofrontal cortex, regions associated with reward, emotion, and decision-making. The same circuitry that drives survival instincts drives your response to a piano melody. The musicologist David Huron at Ohio State University developed a framework to explain this. He called it the ITPRA theory: imagination, tension, prediction, reaction, and appraisal. When you listen to music, your brain is constantly predicting what comes next. When the prediction is confirmed, you feel satisfaction. When it's violated, when the melody takes an unexpected turn, you feel surprise. And if that surprise is resolved beautifully, your brain floods with dopamine. That's the chill. But not everyone gets chills. Research by Sachs at the University of Southern California found that people who experience musical frisson have thicker neural connections between the superior temporal gyrus and the anterior insular brain regions that process sound and emotion. It's partly structural. People who score high on openness to experience in personality tests are also more likely to feel chills. Your capacity for musical ecstasy is, to some extent, written into your wiring. So if music triggers the same reward system as food and sex, why does it exist? This is one of the most debated questions in evolutionary psychology. In 1997, the psychologist Steven Pinker at Harvard called music auditory cheesecake, a pleasurable byproduct of other cognitive abilities, like language and pattern recognition, that evolved for survival. Music, Pinker argued, isn't adaptive. It's just a treat our brains happen to enjoy. But in 2021, over 100 researchers signed a rebuttal in the journal Psychological Science, arguing that music is too universal, too deeply embedded in every human culture, and too biologically costly to be mere byproduct. They proposed that music co-evolved with language as a social bonding mechanism, a way to synchronize groups, strengthen alliances, and transmit cultural knowledge. The evidence supports this. In 2019, the psychologist Samuel Mehr at Harvard studied 86 societies across the world and found for musical universals, the octave scale, steady rhythm, lullabies, and music-dance coupling. Every culture has music. Every culture uses music to bond. No culture has ever been found without it. And then there's the paradox of sad music. Why does a minor key make you feel something beautiful when the content is sorrowful? The neuroscientist Patrick Joslin at Uppsala University found that sad music triggers the release of prolactin, a hormone associated with consolation and comfort. You're not actually grieving. You're experiencing grief in a safe container. The music gives you the emotional release without the real loss. It simulated suffering with a biochemical reward. So here's what we're left with. Music gives you chills because your brain treats it as a survival signal, a prediction system refined over hundreds of thousands of years of social living. The same circuitry that helped your ancestors detect danger now responds to a minor key. The same reward system that drove them to seek food now drives you to press repeat. Pinker was partly right. Music is a byproduct, but of something far more important than language. It's a byproduct of our need to connect. The chill you feel isn't just pleasure. It's your brain recognizing a pattern, predicting its resolution, and rewarding you for paying attention. It's the same mechanism that made human cooperation possible. The philosopher Alva Nu put it simply, music isn't in the notes. It's in the space between the notes. That space, the anticipation, the surprise, the resolution, is where your brain lives. And when a piece of music fills that space perfectly, your body responds with the most honest reaction it has, the shiver. The real question isn't why music gives you chills. It's what it means that a species learned to create vibrations in the air that can make another species cry, dance, or fall in love. Perhaps the answer is that music isn't something we invented. It's something we discovered, a frequency that was always there, waiting for ears sensitive enough to hear it.